Alright, welcome back everybody. In this video we're going to look at the technique that's known as separation of variables and look at a few examples from the separation of variables lesson. First of all, a differentiable equation, dy dx or y prime, that's equal to a function of x and y is separable if we can express it as the product of a function of x and a product of a function of y. So anything that looks like this can be integrated using separation. You see here a big-time Thomas tip. When we're looking at a differentiable equation and we're trying to determine if it's something that we need to use separation of variables on or not, if the variable that appears in the numerator of our differential appears on the other side of the equation, then separation is going to be an appropriate technique. You see in this model up here, the variable that's in the numerator is y. If there's some function of y on the right-hand side, then separation is to be used. If we have dr d theta and the right side contains an r, then we need to use separation in order to integrate. Alright, once we do that, if we have a differential equation of the form dy dx, what we're going to do is we're going to separate all the factors that contain y and dy and put them on one side of the equation with the dy in the numerator. So we're going to bring all the y variables to the dy side and the factors containing x and dx to the other side, and then once we've done that we're going to integrate, and the last thing we're going to do is solve for y. And I say that usually solving for y is the most difficult portion of a separation of variables integral problem. So let's look at example 1. We're going to find y if dy dx equals x squared over y. First of all, I recognize that this is separation because the variable in the differential is dy. In the numerator, the differential is dy, and we have a y on the right-hand side of the equation. So I'm going to use appropriate algebraic steps. I'm going to move the y's all over to the dy side by multiplying both sides by y. And I'm going to move the dx over to the x side by multiplying both sides of the equation by dx. And that gives me this expression, y dy equals x squared dx. The next thing I'm going to do is I'm going to integrate both sides of the equation. So, the integral of y dy is y squared over 2 plus a constant. It's the last time I'm ever going to write a constant on the left-hand side here. And the integral of x squared is going to be x to the third over 3 plus a constant. And then since I have these two different unknown constants, I'm just going to combine them as one constant on the right-hand side. So from now on, I'm just going to put my constant of integration on the right-hand side as we combine these two other constants. Now I want to solve this for y. Not too bad. I'm going to multiply both sides by 2. 2 times x cubed over 3 is 2x cubed over 3. 2 times the constant is just another constant. And then I'm going to take the square root of both sides. So y is equal to plus or minus the square root of 2x to the third over 3 plus your constant. And there we've solved our first integral using separation of variables. On to example 2. We're going to find this function y if dy dx equals x squared y and y equals 5 when x equals 0. A little extra layer here for us. We're going to solve for the constant of integration. So first I separate. I divide both sides by y, and I multiply both sides by dx. And then I'm going to integrate. And so we have the natural log of the absolute value of y is equal to x to the third over 3 plus our constant. And I'm going to go ahead and solve this for y. So I'm going to take both sides of the equation and raise e to that power. So we've got e to the natural log of the absolute value of y is equal to e to the x to the third over 3 plus c. Alright, my left-hand side becomes absolute value of y. My right-hand side, this is a little tricky algebraic manipulation here. But what happens is this is equal to e to the x to the third over 3 times e to the c, and e to the c is just a constant, another constant, and so this becomes that. And now the absolute value I'm going to absorb into the constant, because whether it's positive or negative, it's going to be indicated by the constant. And we end up with this expression here. And now we can solve for c. Y is 5 when x is 0. And so our constant is just going to be 5. And we end up with the equation y equals 5e to the x to the third over 3. And there's our y function given that initial condition in that differential equation. Alright, that's where we're going to stop for now in this video. We'll come back in the next video and look at examples 3 and 4 from this lesson. See you then. Have a great rest of your day.